x to the 6th minus 64 y to the 6th. Okay, here's the thing. X to the 6th is both a perfect square and a perfect cube power. How do you tell if it's a perfect square? So you got something like x to the 6th. How do you tell, just by inspection, real quick, that it's a perfect square? The exponent has to be divisible by 2. Okay? That's it. How do you tell that it's a perfect cube? The exponent has to be divisible by 3. It's both. Well, wait a minute. 64 is a perfect square and a perfect cube also, isn't it? 64 is 8 squared, and it's 4 cubed. And then y to the 6th is both also. So this is both the difference of 2 perfect squares and the difference of 2 perfect cubes. So we have options. Which formula do we use? Actually, you always use the difference of 2 squares formula first. Because if you use the difference of 2 cubes formula, you end up with something that factors, but we don't have a way of doing it. We don't know how to do it. But if you use the difference of 2 squares formula first, you'll be able to factor it completely. Okay, so difference of 2 squares formula, let's write that down, you guys. A squared minus b squared, what does that equal to? You guys know this one. What is it? A plus b times a minus b, or vice versa. You could write it a minus b times a plus b, doesn't matter. And this formula tells us what to do. We have to identify a. So, okay, what's a squared? A squared is x to the 6th, right? So what are we squaring to get x to the 6th? In other words, what is a? X cubed. What's the trick for getting it without thinking very much? Keep the base, divide the exponent by 2. Oh, 6 divided by 2 is 3. That's the new exponent. Verify it. X cubed times x cubed. Add the exponents. You get x to the 6th back again, right? Or x cubed squared. Multiply the exponents, keep the base. You get x to the 6th back again. You could use either law where you have an exponent on the inside, exponent on the outside, you multiply, or where you multiply like bases, you keep the base and add. You can use either law to verify that if you square x cubed, you get x to the 6th. Okay, and then what's b? What are you squaring to get 64y to the 6th? 8y cubed. Plug and chug. What's a plus b? X cubed plus 8y cubed. What's a minus b? X cubed minus 8y cubed. Are we done factoring? In other words, is it factored completely, or can we factor it some more? Both of those, you guys hold on to your seats. Both of those are the sum of 2 cubes. Well, okay, I'm sorry, I misspoke. One of them is the sum of 2 cubes, one of them is the difference of 2 cubes. So both of those factors can be factored more. Isn't that awesome? Yes. No? No. Well, anyway, we're not done. You're not done until you factor it completely. In fact, if this is a problem on the test, I'd say you're a third of the way done, which means you should probably get a third of the credit if you got this far. Because the harder part is with the sum and difference of 2 cubes formula, right? Okay, think about both formulas in one. If you have a cubed plus b cubed, the first factor is a plus b. The second factor is a squared. You got to have a minus somewhere, minus ab plus b squared. How does it change if it's a minus right here instead of a plus? How does it change? Minus here plus here, right? Oh, so that really means there's only one formula to memorize, except you have to remember where the pluses and minuses go, depending on whether or not you have the difference of 2 cubes or the sum. Okay, but there's not as much to memorize as you think. Okay, let's do the first one, and the second one will look the same. The second factorization of the second factor will look the same, except the signs will be switched around. The operations will be switched around. So let's concentrate on this one, you guys. What's acting like A? Yeah, what are you cubing to get x cubed? It's just x. What's acting like B? 2y. So what are you cubing? So look at this guy. This guy is b cubed, right? What do you ask yourself? What are you cubing to get 8y cubed? It's 2 times y. Does everybody understand how to get that? We're going to use the formula in orange, aren't we? For the sum, yeah.
What is the 3 exponent? You just canceled out basically since you're
The way you want to think about how we get a and b is I need the number to get a, I need the number I would cube, or the letter, the variable I would cube to get x cubed. Okay, that's x. What would I cube to get x cubed? X, right? This guy right here is b cubed. 8y cubed is b cubed. What would I cube to get 8y cubed? That's b. Oh, that's got to be 2y. If you want to think of it in terms of a cubed root, really what we're saying is the cubed root, so b is the cubed root, or it's the cubed root in this case. B is the cubed root of 8y cubed. Cube roots radicals split up over multiplication. So you can individually take the cubed root of 8, which is 2, and the cubed root of y cubed, which is y, and that's another way to think of how to get that. It's equivalent to the other way of thinking, oh, what do I cube? The cubed root of 8y cubed is really the question, what do I cube to get 8y cubed? The answer is 2y. So either way you think about it's fine. Now, remember what we're doing. Just for this formula, let's use the formula in orange. Okay? So what's a plus b? X plus 2y. So that's the a plus b part. What's a squared? X squared, okay, minus ab. Yeah, I'll put the 2 in front. So minus 2xy, and then plus b squared. So b squared, okay, here's b, so that's what? Square it, get what? 4y squared. So that's just the factorization of x cubed plus 8y cubed. Just that thing I circled in orange. We still have to factor x cubed minus 8y cubed. But is there a lot of work to do? We look at that factorization we have, and we just change the plus and minus around and rewrite it. So to factor this guy, a and b are going to be the same. So this time we're going to use the formula with the green pluses and minuses. So a and b will be the same. So we don't need to write everything down again. I might need more room. So instead of having x plus 2y, we're going to have x minus 2y. That's the a minus b part over here. And then, everything else is the same except the operation right here. So x squared, it's going to be, instead of a minus, it's going to be a plus 2xy, and then plus 4y squared. So once we factored the sum of 2 cubes, you can easily get the difference of the same 2 cubes, the factorization of the difference of the same 2 cubes. Okay? That's it. I know, you guys look thrilled. You're not supposed to look thrilled. This is the language of math. This is not math itself. This is how we do math. And the interesting problems come later on.